right. We're going to use some of those properties that we just learned to expand a single logarithm into a longer expression. Now, you might ask, why are we wanting to do that? Well, sometimes it doesn't make any sense to do that. Other times, that's going to simplify the expression that we have. So we'll start with a very simple example, log of 10 times x. Well, we learned if we're multiplying those, then we can change that into a sum of those two. Okay, so we've gone from multiplication to addition. And as an extra bonus, okay, log base 10 of 10, that is 1. So depending on what you're doing, this might be the easier expression, or that might be the easier expression. So just whatever's easier. Let's take a look at this guy. It's very similar, except for this time we are dividing instead of multiplying. So that's going to result in subtraction. So whatever's on top minus whatever is on bottom. Need to make sure we've got the same base here. Okay. Now, again, this is kind of nice, except for this is even nicer because log base 5 of 25 is 2. If you weren't sure about that, we can always write this as 5 to the second. This 2 pops out. This is 1. So 2 times 1 is 2. So we get all right. So either way you want to tackle that, as long as you can evaluate that. All right. Here's another one. Well, what do we do? We have an exponent inside a logarithm. Well, that exponent hops to the outside of the logarithm. That is now multiplying. Okay. Is this something we can evaluate? Well, yes, with a calculator. By hand, not so much. Okay. Again, it's arguable which one is easier. It just depends on the situation. Now let's start getting to some more complicated ones. We've got a lot of things going on here. Here's how I like to think about this. I like to think, okay, well, I've got my 4, and it's being multiplied by x squared. It's getting divided by y. It's getting divided by z to the third. You might say, oh, well, these are being multiplied. Yeah, but they're being multiplied in division land. We can still treat them as if they're dividing. So I can say log base 2 of 4 plus log base 2 of x squared minus, let me get rid of this guy, log base 2 of y minus log base 2 of z to the third. Okay. Okay, now that's not completely done. We've got these exponents here that can be moved to the outside. So this stays the same. Three times log base 2 of z. All right, so that's pretty much fully expanded. The only thing is 4 is 2 squared. So the exponent here would be 2. So we could rewrite it like that. So this is the fully expanded form. But once we get good at this, instead of having to do this in 2 separate steps, we can kind of do this in 1 step. Let me try to do that here. So I could write log x squared, but why don't I just go ahead and move this guy out? Plus 5 log z Again, I could have written log z to the fifth, but we can go ahead and move that guy out. These are on bottom, so I'm going to subtract. Log 1,000 minus log y. All right. And log of 1,000, this is 10 to the third. So this is going to actually simplify to just 3. What about this guy right here? I don't see any addition. I don't see, sorry, let me walk that back. I don't see any multiplication here. I don't see any division. I only see subtraction. I do see powers, but it's not a power of the whole thing, so I can't use that, that rule that I've learned. So you might think, oh, well, this is stuck. Well, I'm going to write this in a slightly different form. Some of you might have recognized that this is a difference of squares. X plus y, x minus y. All right. So what does this do? Well, now I am multiplying two things. So I could rewrite this as log base 7 of x plus y plus log base 7 x minus y. That could be helpful to us. That could be not helpful to us. But if you're sitting here going, there's no way I can simplify this, you might take a look and see if you can factor it. Because factoring turns it into multiplication, and multiplication allows us to simplify this. So that's how we expand logarithmic expressions.